Okay, trying again. So I checked the large counts where I took my sample size times what I'm assuming is true for P, and again, I'm assuming this based off of the null hypothesis, always assumed to be true unless proven otherwise. I got 40, and then sample size times the complement of that gave me 460. Both greater than 10, so the large counts condition is met. We can proceed to actually doing this. So when we do this, we state the sample statistic. So they said that 47 of the 500 potatoes selected had blemishes. So what we're seeing is, hey look, we're getting a number that's actually more than 8%. So we have some evidence that it's more than 8%. We now need to see if it's convincing evidence. We do so by standardizing this value. So we take our statistic, subtract value from the null hypothesis, and divide by the standard error of our statistic. So P naught, complement of P naught over the sample size. I'm getting a test statistic of 1.15. So I already sketched my standard normal curve. I'm a little more than 1 standard deviation above center. And this test, based off of our alternative hypothesis, since I'm seeing how likely it is to get something this extreme, excuse me, or even higher, since it's a right tail test, since it says greater than, this is the area that is our p-value. So we're going to calculate that p-value using our normal distribution, normal CDF. I spelled up or wrong. I'm not going back. Again, it's a standardized value, standard normal curve, 0 and 1 for the mean and the standard deviation, which gives me 0.1251. Not very small. This is saying if the null hypothesis is true, a number like this, p-hat value, happens by chance almost 13% of the time, which isn't unlikely. Because our p-value of 0.1251 is greater than the significance level of alpha equaling 10%, we're not able to reject our null hypothesis. We fail to reject H sub 0. We would say there is not convincing evidence. It happens just by chance. That evidence, which there is some evidence, is not convincing that the true proportion of blemished potatoes is greater than 8%. But we may have just screwed up. So because we, how do I want to write this? I'm just going to put failing to reject. Anytime you fail to reject your null hypothesis, you might have made a type 2 error. If you do this, you basically said, hey, I didn't reject my null hypothesis. It's still 8% of those potatoes are blemished. If that's actually an error, it means you just made the wrong choice. And what that actually means is the true proportion of blemished potatoes is some number more than that. Like 10% of your potatoes have blemishes, or 15%, it's some number bigger than 8%. So we were left off thinking that, hey, I don't have evidence that it's greater than 8%, but if it was a type 2 error, we could have made this. We'll never know unless we actually know P, then that's the type of error it would be. Now, your calculator will do a lot of this, just like it does the confidence intervals that we looked at before too. So give me a second to use my camera. Ooh, that's really close up. Ooh, I hope this works. Okay, so if you turn your calculator on, get rid of all the crap that's on here. If you push stat, scroll to tests, that's where we found our confidence intervals as well, but now we're going to be looking for tests. Excuse me. We just did a one sample z-test for P. So I'm talking about a z-test, but I'm talking about a proportion, and we only have a one sample test that we're looking at. I hope you can see that. Okay, up my, that doesn't help. Whatever, I'm going to choose this. It's going to ask me a couple things. First thing it asks is p-naught. This is the assumed to be true p-value. It's going to ask for x, which is the count of successes in our sample. So for our potatoes, we had 47 blemished potatoes. The sample size that was selected from is 500. And then it needs to know what type of test you've run. Our alternative hypothesis has a greater than symbol in it. So when I calculate that, I see the standardized test statistic, I see the p-value, and I see the sample statistic. So those are the three things that I said you have to put in your do step, which means you are welcome, sorry, you are welcome to put this in your calculator and actually make that do all the calculations for you. But remember, screw up, you get none of the credit, but you do need to state all three of those things. The other thing I'll point out is if, when you had found your one prop Z test, if you had instead asked it to draw it for you, it sketches that normal curve and shades that area to the right for you. It shows you that that line was drawn at this particular test statistic and gives you the p-value. Not entirely helpful, but that's what the draw step of that actually does. No, I don't want to do that. Let's, hold on, I know what I'm doing. There we go. So, the do step of that can be done a lot on your calculator. You are more than welcome to do so. The next example on the notes, I'm actually not going to do entirely with you. I would suggest maybe pausing the video, doing it on your paper on your own, or watching the whole video and then coming back to this example 5. The blank copy of the notes is already up on the class calendar. You can just look at it from there. But I would suggest that you do this, because even the practice I'm giving, while it's good, because of the nature of how we're having to do things, you're not actually going through this whole process a lot on your own, and the free response questions will make you do it all on your own. So try this one. I will post my answer underneath these notes videos so that you can check it, but that's what I'm going to use example 5 for. I'm not going to do it with you. The only other one, there's more to do. I lied. The main other one that we're going to do is example 6, and the reason I'm doing this one is because of the type of test this one is. So I'll show you what I mean in a second. So according to the CDC, 68% of high school students have never smoked a cigarette. Yanhong wonders whether this national result holds true in her large urban high school. For her AP Stats class project, she surveys a simple random sample of 150, gets responses from all of them. 90 said they've never smoked a cigarette. Is there convincing evidence that the CDC's claim does not hold true at Yanhong's school? So I'm going to state what it is that I would like to test. So I'm testing what the CDC said is true. So they said that P is equal to 0.68. She suspects that's not true. And if you actually read it, I just want to know that it's not true. She's not saying that no more kids at my school smoke or less than that at my school smoke. She just says that they're not correct. So this will be a little bit different because it's just an inequality. So again, you have to define the variable that you're using. So I'm just going to note that P is the true proportion, or the population proportion, or the way I've written mine, the proportion of all of her school. And I'm also noting that because this is a population proportion, I haven't asked them if they've smoked a cigarette yet. So this is just those of them who would say that they've never smoked a cigarette if they'd been asked. And I need to also include what level of significance we are running this test at. This is still a one sample Z test for the population proportion, so I'm going to note that in my planning stage. I need to check for randomness. So it says that she surveyed a simple random sample. So she selected without replacement. So we'll have to check the 10% condition. The 10% condition, I went ahead and wrote out. 150 students is going to be less than 10% of all students at a large high school. The large counts condition, remember you take your N and multiply by your assumed to be true p-value. So I'm getting this from my null hypothesis. And it's bigger than 10. If I do the same thing with the complement of that, 1 minus 0.68 is 0.32. I'm going to get 48 people, both at least 10. The sampling distribution of sample proportions would be approximately normal. So I can go ahead and go to my do step. Now, again, you can go to your calculator and get these 3 things, but you do have to write them all down. You have to write down your statistic from your sample. So 90 of the 150 sampled said that they've never smoked. You need to write down what you get when it's been standardized. Your calculator will spit this number out. You just need to write it down if you're going to get it from your calculator. But I'm also going to note that it's your sample statistic minus the proportion parameter value from the null hypothesis, and then taking that null value times its complement over your sample size under a square root. This would be the stage I'd probably double check it with my calculator because there's a lot of stuff going on in there and it's really easy to mistype something. So our p-value will be standard normal curve. I'm more than 2 standard deviations below our mean, but this is a two-tailed test. I don't just want this area. We also want the area to the right of positive 2.10. You could find those 2 separate areas and sum them together. That is 100% correct. So, how am I going to write this? The p-value is the same thing as the probability that you get a z-score less than or equal to negative 2.10 or a z-score that is greater than positive 2.10. So it's symmetric. That's why either one of these could be true, or means you could just sum those 2 values. This is the same thing as just doubling one of them. So I'm going to just do 2 times the area in one of those tails. Most common mistake if you do this by hand, not doubling it. I guarantee if we actually had time to do all this in class and I had time to give you homework and all that good stuff, there'd be a bunch of people that consistently forget to double it. So I'm going to find the area in the left tail, but it will need to be doubled. So when I do that, I'm getting about 0.0357. So, oh no, my stupid screen just froze. Give me a second, sorry. So, we conclude this by comparing our p-value, which is 0.0357, because that number is less than the chosen level of significance. We're basically saying this is really unlikely, assuming the null is true, so let's just quit assuming the null is true. So we have convincing evidence that the proportion of all students at her school who would say they've never smoked a cigarette is something different than what the CDC has said that it is. We just think that it's not equal. Now the thing is, that's well and good to be able to say, yeah, not that number. But that's really all a hypothesis test is good for, to be able to confirm or deny some claim. It doesn't really give you a ton of information. A confidence interval gives more information. So again, what I just said, the result of a significance test begins with a decision to reject the null or fail to reject the null. In the smoking study, we rejected the null hypothesis. We had convincing evidence that the proportion is something different than the CDC's claim. But we're left wondering what the actual proportion for P may be. A confidence interval can shed some light on this. So if I did a 95% confidence interval, so don't forget this was our formula for it. So we start with our point estimate. Her sample statistic was 0.60. And we would add and subtract our margin of error. So this would be our critical value at 95%. If you remember, it was 1.96. And then you multiply. Now this is slightly different. We just used the p-naught value whenever we did our test. But if you remember, this here, I'm blanking on the actual official name for it. When we did this, our standard error, I think it's standard error. Yeah, the standard error for the confidence interval is based off your sample proportion p hat, whereas when you run it with your, what am I trying to say? When you do your test, we put in the P naught value. So this is going to be slightly different. They're not always going to be 100% consistent with each other. But what this would mean for this problem, your point estimate will have that for the margin of error. So this is able to say that the plausible values for the population proportion are anywhere from 52.2 to 67.8%, which is a lot more information than just saying, yep, it's not 60. This actually gives us some evidence, though. We shouldn't be surprised if any of these values show up. Remember, those are the plausible values for P. These are not surprising. We would be surprised by the null hypothesis of 0.68 because that's not in our interval. So we would still get the same result of rejecting the null hypothesis. It just also gives more information of here are the things that we think it should be. I already pointed out your standard error for the confidence interval is based off of your sample proportion, so it is going to be slightly different. I summarized how we found those two values, but it is useful information. The last example that I'm going to kind of skim through, yet another problem. They're trying to figure out if job stress is bad for their health. So they're claiming that 75% feel that it's a negative impact. And where'd I go? The manager wonders if this is valid for the employee. So they don't wonder if it's more or less, just that if it's different, which is highlighted here, if it's different than 0.75. Now, if I should have gone through when I did this and went through and stated everything, planned it out, and then did it. For time's sake, I decided not to do that, especially because it was supposed to show this program called Minitab. It was supposed to, if I had remembered to type it up, it was supposed to give all this information already. So there is one sample. This is the count of success. This was the sample size, the sample proportion. This is the confidence interval. We get the standardized test statistic and the p-value. So the reason I skipped a lot of this is because it did it for us, which is really nice. We can go ahead and jump to our conclusion. If we had done the full significance test, if we had done that, then our p-value, which is here, our p-value of 0.106 is in fact, what is our level of significance? Yes, Alex. Sorry, your kid's back. Okay, good. Go back upstairs. I'm very proud of you. Go upstairs. Don't have kids. I love them, but don't have kids. Okay, so because this is greater than our level of significance, we can say that we should not be rejecting our null. This is common enough by just chance alone if the null is true. So we don't have convincing evidence that the true proportion, the blah, 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 stress as a negative impact is different than 0.75. So I think it's still 0.75. However, if you are looking at the confidence interval, which again is written out for us here, we can come to that same conclusion. If I look at the two thresholds for what are plausible for P, 0.75 is one of them. So 0.75 is a plausible value because it's within the 90% confidence interval. So based on the confidence interval, we would still come to the same decision that we would fail to reject. We would not. We would fail to reject. And I don't really want to talk about a null if I'm talking about a confidence interval. I'm just not rejecting this is a possible or plausible p-value at this particular significance level. So the 90% confidence interval provided gives an approximate set of p-naught values, so numbers for the null hypothesis that would not be rejected by a two-sided test at the 10% significance level. So would not be rejected. I think I wrote out. Yeah. I mistyped it here. This was 90% confidence interval. So it gives a little more information. It gives the plausible values, but it comes to the exact same conclusion. So now I'm officially done, and not just because kids are barging in and making me talk to them instead. So I apologize, this was in so many pieces. Again, email me if you have questions, run through the samples. If you are on the fence of deciding whether or not to take the AP test, remember you can decide that at any point. You can do that now if you're super stressed, or you could do it later as you get closer to it. They're supposed to come up with more information on what they're actually going to be assessing. Like, I know what units it should go through, but it made it sound like they're going to give details on what's actually going to be on this test. So I'll get information to you when I know it, but for now, trying to get as far in the notes as we can because things are weird, and yeah. So go wash your hands, stay away from people.